Okay, so hello everyone. You're welcome to today's data analytics bootcamp. In today's bootcamp, we are going to look at Python data analytics projects, portfolio projects. Today, our lesson will be divided into two. We will have the data cleaning part and then the exploratory data analysis part. So we are going to clean data and then we will also do data exploration. Okay, so today's activity is actually divided into two, and we are going to combine the two of them together. Okay, so we are not going to waste much time. Let's just start straightforward. All right. So as usual, if today is your first time, remember to subscribe, like, and share with your friends. Okay, and if you are a returning viewer, do same. Kindly share with your friends so that they can also have access to our studies. Okay. So the data set we are going to use today, because we are doing two things together, we have the data set. You can check it from the description. Just go to the GitHub and then you download the two of them. There are two data sets that we are going to use today. We are going to use one for data cleaning, and then the other, we are going to use the other for exploratory data analysis, where we explore to understand the data very well before further analysis. Okay. So the first thing that we need to do is, as usual, let's just open Jupyter Notebook. So we have so once our Jupyter is open, we are just going to open new. Okay, so let's just open new, something new. And then the first thing we want to do is that, because we want to do data cleaning, let's rename this one as data cleaning. Okay, so let's just rename data cleaning. So data cleaning in Python. Good. Now we have renamed our two things, our work. So as usual, as we are starting, as I said, data set is in the GitHub repo. We have two data sets. When you come to the repo, you have two data sets. You have the customer call list, and then we have the homicide by countries. Okay, so one is Excel and one is CSV. Okay, so the first one that we are going to use is the customer call list. That is what we are going to use to do our data cleaning, and then we use the homicide by countries to do exploratory data analysis. So let's just head forward. So the first thing that we will do is that to import our libraries. Okay, so if you have not installed the libraries, as usual, the way you install them is that we have the exclamation mark, then you have pip install. So pip install pandas. That's the first thing that we are going to use. Then the other one is pip install. We want to install we have numpy. Okay, so these are the two data set, the two libraries that we use to do our data cleaning. Basically, the data cleaning is fully focused in pandas. That is what we use to do full data cleaning. So these two ones are the ones that we are going to use. Now, because I've already installed them, I won't run it. Okay, there is one data set that there is one library too that I want us to install, and that library, it will help us use, because we'll be using a data set from Excel. This library will help us be able to pick our data from Excel. Okay, so that one too, we have pip install. Okay, so that one is the open Pies XL. Okay, so it is used to, we use it for that is reading data from Excel. Okay, so you have install, pip install, we have the open Pies. Okay, so this is how we import it. If you have not installed it, you have to install it first before you can read the data from Excel. Okay, without this, you can't be able to read your data from Excel. Okay, so that is just that. So all right, so now let's import the libraries. Let's assume that we have already installed all the libraries, and then what we need, the next thing that we need to do is to import the libraries. Okay, so assuming that we have already imported the libraries, we installed all the libraries, we need to import them. So import, okay, we have Pandas as PD as usual, and then the next one to be import NumPy. So import NumPy as NP as usual. Okay, so once you finish importing them, we need to run. So we run it. So yes, our libraries are now loaded inside our file, and then the next thing we need to do is we need to read our Excel file. Now when you open your Jupyter notebook, the folder that you open your Jupyter notebook in, if the data set is in that particular folder, you will see it there. For example, the folder I'm using, I have the data set inside. So we have the first data set as, we have these two data sets. Okay, so these are the two data sets we are going to use. Now one is Excel and one is CSV. The customer data set, that is what we are going to use first. Okay, so this is what we are going to use first. Okay, if I click on it, it should, good. So it will open in Excel for me. It will open this way for me. So I'm interested in, let me just copy the name of the heading. Okay, let me just copy this. It's won't, so let's just forget about it. You are not interested in that. Okay, we are not interested in opening it. I'm just interested in copying the name so that I can be able to import it. So now let me read the data set, and I want to assign a variable called df, which is just a short name for data frame. So I say df, and then it's equal to, and because we are using Pandas to read our data, I will use a pd. So I will say that import pd dot, and then I will read from, anytime you are reading from Excel or CSV, we use the word read. Okay, so either read CSV or read Excel. Now we are using Excel, so I will say read underscore Excel because I'm reading from Excel. Okay, now that is very important. The important thing you should note is that if you have not installed this particular library, okay, if you have not installed this particular library, you cannot read from Excel. It's going to give you error. So you have to make sure that you install this particular library before you use the read underscore Excel. So I will open it, and then I'll open my parentheses and paste the name of the data set inside and close it. Now, if you happen to have your data set into another folder indicated over here, you have to make sure that you quote the folder name. But in my case, I don't have the folder. I don't have any folder. The data set is just inside where my code is. So I'll just close this bracket. Okay, and then down there, maybe I want to look at the data set. So I'll call the df and then run it. So when I run it, it should be able to read my data set for me. Good. So we have our data set that we can see. It's just giving us a glimpse of everything that we have in the data set, where we see the customer ID, the first name, the last name, the phone number, address, paying customer, do not contact, not useful column. Okay, so it means that we have to look at this data set, and if you look at a glimpse of it, you realize that we have even the phone number section. The phone numbers are not the same. You can see this one with hyphens, you can see this one with slash, you can see this one, the next one, this one with nothing. So, and this one with the kind of, it's not worth it. And then when you also look at the other parts of this, okay, here it shows that do not contact. We have yes, no, yes, no, yes, no, why, and co, which means that if let's assume that we want to clean this data set for our clients, okay, so that they can call. Our clients want to get a clean data where they can contact their customers. So it means that this particular place, there are some customers that they don't want the shop, or they don't want the business to call them. They don't want anybody to contact them. So those people, we have to filter them out, and then only give and filter the customers that are willing to receive call to our client. And also we have to make sure that we clean the phone number also well, and make it good for our client to be able to contact, because with this we won't even know whether it's a good phone number or not. In addition, when you look at the last name column, you can see that we have some backslash over there and stuff. So it means that we have to make sure we clean all those things and make our data set very clean for our clients. So that is what we are going to do. So the first thing that we need to do is that we want to check if there is a duplicate in our data set. Okay, we want to check if there is any duplicate in this particular data set. Do we have any duplicate? Okay, maybe perhaps the administrator in charge of inputting these particular names by mistake repeated a particular name twice. So we want to check if there is anything like that. Okay, and because we are dealing with PD, we will say that PD dot, and then we use the word duplicate, so duplicate, and then you open our parentheses. So duplicated, okay, and then you would hit OK. So we can see that we have, since once we type df.duplicated, we will see false, 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 showing that they are no, there's the rules, they don't have duplicate. But you can see that we have one, the last one as true, showing that there is a duplicate in the data. So once we have true, it means that there is a duplicate. Okay, so we need to remove this particular duplicate. We don't know, we can't go through the data one by one. For example, if you have a very large data set, we can't go through it one by one. The only thing that we can do is to check if there is a duplicate, and we try to drop that particular duplicate. Because if you want to go through the data one by one, it's not going to be easy. For example, if you have like 30 million data rows of data set, we can't go through it. So let's just drop any duplicates that we have. Okay, so, and what I'm going to do is that I want to drop the duplicate and resave it to this same variable data frame. Okay, so I'm not ready to change the data. I'm not ready to change the name of the data. So I'll just save it to that same. So I'll say df now is equal to, so that I want to override it, and I'll say df dot drop. I'll use the keyword, the word drop. Okay, duplicate. Okay, drop underscore duplicate, and then I'll put open and close brackets there. So now if I put my df and then run it, it should just give me, it said error, we don't have data, have no attribute, drop underscore duplicate. Maybe perhaps you made a spelling mistake. Okay, yes, it's supposed to be duplicates. So good. So once we say drop underscore duplicate, we've now run our data set again. But let's also check again. Let's use this keyword to check again if we still have the true is also still in again. So let's say this and then rerun it. So now we don't have any duplicates again. So all of them are false, showing that there is no duplicate in our data set. Okay, so let's continue moving forward. Now, because even in our data set we have one column saying that not useful column, since it's just the heading is just not useful, it means that that particular column will not be useful. Now, in fact, our client will only be interested in the customer ID, the first name, the last name, the phone number, the address, and then customers that would want them to be contacted. Okay, so those are the only things that our clients will be interested, since they want us to clean the data so that they can have a clean data to make calls. So we want to drop this particular data, so we want to remove this particular column. So I will say that df is equal to df dot drop. Okay, df dot drop, and then I'll open parentheses, and I'll say I'll specify the column that I want to drop. So I'll say columns is equal to, and then I want to drop this particular column, so I can copy the name of the column. I can copy the name of this particular column so that I don't make mistake in retyping it. So I will say, and then I'll open parentheses like this, in quotes, and put it, and then close it. Okay, so if I call the data set again, okay, let me just run this, and then in my next, let me call the data set back again. So you can now see that that column is gone. We don't have it again. So once we use the df.drop and we specify the column heading, we have dropped that particular column. So we don't have that columns again. Okay, so that is how we drop the column. The next thing that we need to do is that we want to come and now look at the phone number. Okay, the phone number and then the last name, since we have this backslash over there. And if you go through again, you can see we have some dots. We also have some hyphens or underscore there. So we want to clear those ones away. So here we will say that, okay, let me give a comment and say that, okay, clean last name. So let me just give a comment saying that I want to clean last name. So now, because I want to clean it's only the last name that I want. Okay, so I will call that particular column, and then I will do my cleaning. So df, then I'll open the square bracket, open quotes, and put the last name inside, close it, and I'll say is equal to. So that is the only column that I'm interested in. Okay, so I'll say equal to, and then df again, and then I'll open it again, and then I'll say the last name again is equal to. So now what do I want to do? I'll say dot, because it's a string function. I want to use the word string, and then there is dot strip. Okay, dot strip. Now the strip work like the way we use trim. Okay, it just work like the trim function in Excel, where we trim any space and then any other things. So the strip functions is actually going to, when you use the strip functions, we are trying to strip away anything that is not related to that particular thing. However, we need to specify the structure of the thing. So inside we open parenthesis, inside over here we will give quotes. Okay, the first thing that we want to strip off is that the backslash. So I'll specify the backslash. Then the next thing I want to strip again is there are dots here. I don't want those dots before the name. If you look at this particular one, there are dots before the name. So I want to also clear away that dot. I'll put that dot there. There's also over here something over here called, you have underscore. We have some underscore also as part of this particular name. So I also want to strip that away. Okay, so underscore. Now there are only three things I've noticed. So I'll close this, and then I'll run it. So once I run it, let me call my df again and see. Good. So once I call the df again, you can now see that those things are gone. Okay, the backslash was here. We have the dots here. We also have the underscore here. So we have taken care of that one too as well. Okay, so we have cleared away that one as well. Now my focus is now on the phone number. So how do I make sure that I clear away those particular phone number and make them look like a particular format? Okay, so that is my interest right now. How can I be able to put the phone number into a particular format so that it will be the same. Now, for example, we have a phone number, we are having something like maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. If these are the phone numbers, now you can see that some are with hyphen, some are with hyphens, and some are with backslash, and some are not with anything at all. Okay. So what I want to do right now is that I want to make sure that I have the same phone number, the same format. Where, for example, maybe I want to use 1, 2, 3, then I'll put hyphen there, and then 4, 5, 6, another hyphen, 7, 8, 9, then maybe 10. Okay. So I want to put the phone number, all of them to have the same format like this. Okay, because this look better than with backslash, forward slash, and stuff. So because I want that, that is what my focus is on right now. Okay, so let's begin doing that. First thing I want to do is that I want to df dot phone number. Okay, I want to see how the phone number look like. So I want to remove all the phone numbers. So you have the phone number, and then good. So now I can see the phone number clearly, where we have some with hyphen, some with backslash, some with nothing at all, and then it's not appealing. So I want to make sure that all of them have the same format. So that is what I want to do. So the first thing I'm going to do is that I'm going to try to standardize this particular phone number so that it will have the same format. Okay, and I'm going to use I'm going to use something that we have a regular expression. Okay, we have something that we use a regular expression, regex. With that, I want to make sure that the phone number have the same thing. I want to clear away with that. What I want to do is that some of the phone numbers are with backslash, some of the phone numbers are with, I want to clear away all these things. Okay, I want to clear away anything, those with space, and I want to clear away anything so that it will have the same thing before I can move on with anything I want to do. So that is what I want to do right now. So I will say df, then I'll open my square brackets and I'll say phone number, phone underscore number. That, so I'll say that is equal to the same thing df again, because I'm trying to save it inside the same data frame again. Okay, so df, so phone number, so our phone number. So I'll close it and I'll say that string dot string, because it's a string, so dot string dot replace. So replace, and then I'll open, and then I'll use, so I have this as R. I'll explain this a bit. I'll just explain this in a bit, what I'm doing here. df d, so this, then I also have, so I want to, wherever I see these things, I'll put something like this. Okay, then comma. So, and I'll say that the keyword rejects. So I'll say true. Okay, so this is what I have. So if I run this, good. So sorry, there's a mistake here. We have, it's supposed to be this way. Good. Yes. So now let me type df again, and let's see how the phone number look like. Good. So you can now see that the phone number is now, those hyphen, backslash, everything has been cleared away. Those things are all clear away, and then we now have a clear phone number where we don't have any of those things. Okay. Now let me explain this particular method that I'm using over here. So this is a regular expression, and the phone number part is just to access the phone number over here. So I'm trying to access the phone number here, and then I'm trying to save it inside the same data frame again. So whatever that you do over here, replace it with the same phone number. so that when I call my data frame, I will still have my phone number column that. But then everything, the changes over here, everything over here will now work and to replace this particular one. Now the next part is that the st dot replace. Okay, the st dot replace will allow you to use a string method on each element of the series. Okay, in this case the phone number column, it will, like the string column of the phone number, it will use that particular column, and then replace method, and it will use it to replace occurrences of any specified patterns. Okay, so for example, any pattern that we have here, these particular things that I'm specifying here, I'm trying to say that, okay, any patterns, if you find any of these particular patterns inside, replace it from the phone number. And when you come to this part, okay, this part is what I'm using to do it's called, that is the regular expression that I'm trying to use, and it's used so that it's actually identify the patterns, and then the /d is the matches. Okay, it matches any character. So for example, any particular character we have, any character that we have inside over there, okay, that is not a digit. If that particular character is not a digit from 0 to 9, okay, I'm trying to say that, okay, go through the phone number, go through this particular phone number, and wherever you don't see, you see anything that is not like from 0 to 9, replace it with this empty space. And because I've not given it a space, I just give a close close quotes. It's not going to give any space. Should I put a space here, it's actually going to put spaces between wherever I find those things, but I don't want any space, so it's not going to put anything there. So let me just show you something. So what it's doing is that, okay, the r apostrophe //d, this, it's just trying to say that, okay, so go through the phone number. When you go through the phone number, whenever you see anything that is not from 0 up to 9, replace it with this apostrophe, where these things, replace it over here, whatever I'll specify it. So for example, if I should have specified, for example, I should have said that replace it with dash, it will put dash wherever it sees these things over there. But because I've not specified anything over there, I close this particular thing and just make it like just only to something, a close quote. It's not going to put anything there, but then it will just move away. Okay, however, it's going to, this particular expression is actually going to search to remove anything that is not a number 0 to 9. Okay, and then I'm saying that replace is equal, reject is equal to true. Okay, it specify what the replace to do. Okay, that is when the replace matches the character with, in this case, like we have the replace not non-digits. Okay, so it's actually going to replace non-digits, and it's saying that replace it and make sure that particular thing you replace it, and then I'm specifying it to be true. Okay, so the parameter indicated that should the argument in the regex expression, so just replace it for me. Okay, so just replace that particular parameter for me, and so that is what the other expression is doing. This particular one, that is what it's doing. So it's replacing, it's making the replace true, so that it won't, anytime I call the data frame again, okay, it will stay inside, nothing will change. Okay, so that is what I'm doing with my regex function. Now let's move on again. Okay, we are not done with the data cleaning, the phone number cleaning. Even though I've now standardized it, I want to make the phone number in this particular format, so that I'll have maybe 1, 2, 3 hyphen 4, 5, 6 hyphen, and then 7, 8, 9, 10. I want to put the phone number something like this. So that is what I want to do, so that it will be clear enough, so anyone that picks the data set can be able to easily spot the phone number. So that is what I want to do right now. So here, what I will do is that I will change the name of the phone number. Okay, I'll change the name of the columns. I'll create a new column. Let me put it. I'll create a new column and name it maybe clean phone number. Okay, so maybe I want to change it to maybe clean phone number. So I'll say df, then I'll say clean underscore phone number. Okay, so I will say is equal to. Now I want to check. First thing I want to check is that I want to check if the phone number is indeed 10. Okay, if the phone number is indeed 10, if it is not, if it is equal to 10, then space it out for me, split it for me. So I'll use the NP. Okay, I'll use now I'm going to use an array, which is a numpy. Okay, I'm going to use a numpy to perform this. So I'll say NP where NP dot where, and then I'll open parentheses like this. So let me break what I want to do here down. So let me break it down and I'll say that, okay, so the first thing I want to do is that df, the name of the phone number, the column, the name of the column, and over there it's phone number, phone underscore number. So then I'll close it and I'll say that dot, if it is dot, this is a string function, then I'll use the length function. The length function actually check, okay, it's used to determine the length of a character value. Okay, so here I say that should be, and then I'm using this operator, that is comparison operator. So is it equal to 10? If it is equal to 10, then do the following for me. So let me just copy this. So I want to do repeat the same thing. Now here I'm going to slice the phone number. Okay, so I'm going to slice it into maybe 3, and then maybe 4 like this. But just as yesterday I said, we have the indexing where we have this one is giving the index 0, this one is giving the index 1, this one is giving the index 2, this one is giving the index 3, in that order. Okay, so that is what I'm going to do, is that I will say that from 0, from this particular 0, 3, okay, and I'll slice it into 3. I'll say from this particular to 3, put this particular thing between them. Okay, so, and I'll use the function, the concat function. I'll use maybe like addition, so that it will just be added. So let me say slice, so slice, and then I'll open. So the first parameter, I'll say 0, 3, and then so I'll do concat plus. Okay, then the I want to, it's a string function, so I'll put this there and then hyphen this like this, and then I'll concat it with another one again. So I'm trying to concat it with the next one. So I'll just copy the same thing over here, and then I'll now replace it. I'll now paste it. So let me go down again, and then so this one, since I'm ending at the 3 over here, I'll start from the 3 again. So I'll say from the 3, and then I will move to 6, and here I'll from 6 I'll move to 10. Okay, so this is what I'm trying to do, and then comma. So the next one will be like any other thing should be none. Okay, this should be and that is not a number. Any other thing that it is not, if once it is not equal to that, if it is not equal to 10, make it not a number. Okay, then I'll close my bracket. Okay, so I'll close my bracket. So I'm trying to concat them. For example, I slice it into 3, from 0 to 3. Then once I pick those three values, for example, once I pick the first 3, maybe 1, 2, 3, then I say that, okay, plus, then I put this hyphen there, then I'll say plus, then I move to the next line where I specify from 3 to 6. So that one becomes 4, 5, 6. Then I say plus. Okay, so I say plus, then I put the another hyphen there, then I say plus, then I now move to from the 6 to 10, which is 7, 8, 9, 10. Okay, so it's like these particular plus are the ones that are doing the concatenation for me. Okay, so they are adding them together for me, and then these particular ones are the things that I'm putting between them. These are the hyphens that I'm putting between them. So that's what I'm doing. And then the next one, I'm saying that np dot nan. So if you don't find, if for example, where I say that where we have the length of the distance, the length should be equal to 10. Okay, where we see that string, sorry, the string, okay, the length of the string, where we have the, what do you call it, where we have str dot length, we say that this should be equal 10. So if this condition is not satisfied, then make that particular number as not a number. So that is what I'm doing over here. So let's just run this particular thing, and then we check the phone number again. So now we can now run our df again. So good. So you can see that clearly a new column has been created, and this particular column, cleaned phone number, has been created for us. And this column, all the phone numbers have been given the particular that order. The hyphen has been put in place of them, and any other thing is given the not a number, not a number, not a number. Okay, even this particular where we don't have nothing there, it's just a space, was given not a number. So that is how it, and this part is given not a number. So that is what we have done, and we have achieved what we want to do. Once that we have achieved what we want to do, and this become a clear phone number for us, I think we can drop this particular one. We don't need it again. Okay, we don't need it because we are cleaning the data. So we are going to use the df again. So we say df will be equal to, then I'll say df dot drop. Okay, and I'm dropping a column. So df dot columns is equal to, the column is the phone number column. The phone number column. So I can close this, and then I'll put my df again. Good. So now the phone number column is gone. Okay, which means that this now becomes my phone number. So gradually we are removing things that are unwanted things. Okay, missing values, unwanted things, and then we are making the data look good for our clients. Okay, so now we have been able to achieve all these things, but however, this not a number, not NAS, it doesn't look good in our data set. It doesn't look good inside. Okay, for example, a client that doesn't have any idea of what this is may be confused. So we want to just remove it. Once there's no phone number there, we just want to make it a blank space. Okay, we just want to, once there is no phone number there, there's nothing there, we want to make it like it is blank. Okay, so what do you want to do? What I will do is that I would change this phone number column. Okay, where I will remove all those things. I will fill those with space empty. Okay, so let's say that let me give it a comment. Let me say that maybe I want to so let me say that I want to display. Okay, so let me try to give it, okay, display. So I want to say display the so let me say phone number column. So phone number column, the phone number column. Okay, I want to display the phone number column without the NAN. Okay, so I think this comments you okay. So I'll use df, and so okay, I have clean phone number, okay, phone number is equal to df, so it's just the same thing. So let me just copy the same thing. Okay. Now I'll say dot, and then I'll use the word field. Okay. The field. So I'm using field NA. Okay. The field NA is used to just remove any value. Okay. Wherever that we say not a number. For example, as soon as I specify this, whatever I'll write inside this. Let me close this one. Now, whatever I'll write inside over here, whatever I'll write over here, would go and replace wherever the not a number, the NaN is. Okay, wherever we have NaN, this particular whatever I'll type here will go and replace that. So because I don't want anything to be there, I just want that place to be empty. I'll just leave it like this. I won't even give a space. Okay, I'll just leave it like this. So, and then I'll run. So once I run it, and then I call my df again, it should clear away those ones. So you can now see that those places with the NaN are now with spaces. They have nothing there. This look good for us because we don't know our client. It may be that he doesn't have any idea of the NaN. He doesn't even understand the meaning. So because of that, we don't want that to be in the data set. So we have tried to remove it. Okay. So that is what we are going to do. Now, because we have been able to clear away that, the next thing that we also want to look at is that if you look at the address look like a combination of 2 or 3 things. For example, when you come here, you can see that perhaps the first one is the street name, and then we have the state, and then we also have some other stuff over there, which we don't even know what it is. So we want to split the address in a way that our client can be able to understand. So what we are going to do is that we will split this particular column into 3. Okay. So let's maybe that I will just take this one as that. Okay, this one is the zip code, and then this is the state, and then this is the street name. Okay, so it's like a street name. Before you have the street name, the state, and then the zip code. So I will change this particular, I'll split this column into 3. Okay, so that is what I'm going to do. So I will say df, and now I'll split, because I want to split the column into 3. The first one that I want to give is that I want to split into 3. So I'll use 2 square brackets. So the first column I want to create out of the address is maybe street. Okay, so maybe street address. Okay, so let me just say that street. So you have the street address, and then the next one I want to create is the state. Okay, so I want to create state, and then the next I want to create is I will say zip code. So zip code, and then I'll close this, and I'll say it's equal to df, the column that I want to split. I'll now specify the column that I want to split. The column I want to split is the address. Okay, so let me check if that is the correct name. We have the yes, the address. That is how it was written. Okay, so that is now how I want it. And then it's a string value, so I'll use the str, and then I'll dot split. Okay, s dot split. The split will now split this particular thing into, it will split it into the specified columns over here. Okay, given a particular condition. Now I'm using split. How do I want to split it? Okay, the first way I want to split is the part. This particular one would, so it will be equal to, and then the part will be like, it's like, okay, how do you want to split it? Where exactly do you want it to move and split? So when you see it, we have comma inside. Those comma, we have comma. So I'll say that, okay, so when you move along the line, when you move, you are going through the address. Wherever you see comma, split it. Okay, wherever you see comma, split it over there. So that is what the part is doing. So it's like this. I'll give this one, and then I'll use the comma. So, and then I'll give a comma, and I'll move forward. The next one is how many columns do I want to create out of it? Out of this particular thing is given as we have 3. I want to split it by 3 columns. but because this one is there, I will specify n as 3, okay, so that I will say that n equals, so let me use 2 and let's see what will happen. So like this, and then the next one will be that I want to expand it. I want to expand so that they will be on their own. Okay, so I'll use the expand keyword and I'll say expand, and I'll say it's true. The expand is true. So I can now close this. Okay, so I can now close this. Let me run this and see if this works. So let's check if this works for us. Good. This, yes, it has worked for us. Okay, so we now have the state. So you could see that wherever there is no state, it will put none there. Wherever there is no state, it will there is no zip code, it will put none there. I think we are okay with that. Okay, and since we are okay with that, we can drop the address name. We can drop this particular address. Maybe we don't want to take it. Since we have gotten this particular one, it should be enough for us. So I'm going to drop the address column. So df should be equal to df dot drop, and then I'll specify the column that I want to drop. Columns equals, and then I want to drop the address column. So address column, and then if I call the distance again, good. And now there's no address anymore, so it means I've dropped the address column. So now the address has been split into different. I now know the street address, the states, and then even, okay, all right. Now another thing that we can see from our data set is that when you look at we have the paying customer and the do not contact. We have yes, no, and yes, why. It doesn't have any format. All the formats are not good. So it's just like yes, no, yes, yes. So that is how it's supposed to be. So if all of them are going to use yes, no, it should be yes, no. If all of them are going to use y for yes and then n for no, it should be throughout. It shouldn't be the mix-up. So I'm going to try to clean it so that I will make it uniform. Okay. So if it is going to be yes, 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 I want to make all of them that. But I want to make all of them as yes will be y, no will be n. So that is what I want to do right now. So I will say df, and then the first one I want to look at is the customer do not contact. Okay, do not contact column. I want to clean the do not contact column. So I'll do this, and then and df. So now df, I'll do that again. Okay, so what I want to do is that dot is a string function, then I'll use a string, and I'll do dot replace. Now I want to replace anything inside. What do I want to replace? The first thing I want to replace is whenever you see yes, okay, whenever you see yes, replace it with y. Okay, that like this. So this is what I want to do, and I'll copy the same thing and do it for the no too. So the same thing, wherever you see no, replace it with n. Okay, so I think this should be okay. Now let me run it and check df. Good. So you can see that with the do not contact column, we have been able to filter out. Okay, do not contact, yes, no. So we don't have any no, yes again. We only have not a value inside, and we'll take care of that in a bit. Okay, now I want to do the same thing for the paying customer. Okay, I want to do the same thing for the paying customer. So without wasting my time, I'll just copy the same thing and then come here and paste. Now I want to change the name. The name is paying customer. So over here it is paying customer. You have the paying customer. So around this, Let me also check. Good. So that one to have been taken care of. Okay. Now, when you look at it, when you look at the data set, you could see that this particular place is having n/a. Okay, and because we don't know what that means, we can just leave that one in. We can just make it like, okay, let it be inside. We can't consider it to be not a number, so we can just leave that one inside. All right. So the next thing that we want to do, one thing that we shouldn't forget is that our customer is only interested in what do you call it? Our customer is only interested in contact that they can call, because it has been clearly specified. Some of them, they said do not contact, and some of them say contact. Okay, but before we do that, we have so many non-values, we have so many this one, not a value and all those stuff, not a number and so many things inside. So we want to take care of those things. Okay, so what I'm going to do is that I'm going to fill all those not a number with a space, just as the way I did for the phone number. So here, what I will do is that I will say df is equal to, okay, df is equal to df dot fill na. Okay, and inside I'll just close it like this, and then I'll call the df again and see what happens. Good. So now, as soon as you do that, you have even cleared away none and not a value inside, and this makes the data set look good. So this has made our data set look good. It's only this one, n/a that are in. We can leave that one inside. Now we can clearly focus on now our customer, because our data set is now clean. Okay, we can decide to end here, but because our customer is only, we need to get those that perhaps they are we need customers that accept to be contacts, because we need those ones. We can try to filter away only those ones. We can try to bring those ones in so that we can be able to contact them. Okay, so we can do that so that we will get only customers that are saying that, okay, yes, you can call us. Okay, we can try to check those ones. So we will try to filter all these areas. We try to filter all these areas. The first thing that we want to filter is that this one. Now, it's like do not contact. Yes. So it means that those people, they don't want the company to contact them. So what I will do is that I will try to drop out all those that say that do not contact. Yes. I'll remove all of them, so that we will be left with only people that say do not contact. No. Yes. It means that when they say no, it means that you can contact. Okay. So I will drop all the yes and leave only the no, because all those people that say no means that yes, you can contact them. Okay, because the statement is do not contact. They said yes, so it means that they don't want to be contacted. So I'll try to drop all of them. Okay, and one way I can do that is that I'm going to use if statements. Okay, I'm going to use if statements to iterate through and drop those things. Okay, so I will say that I'll use both if and for statement. Now I will say if I'll base on this particular index to drop them. So I will say that okay, so let me say for I in df dot index, then I'll come here and I'll say that if df, okay, if df, then I'll lock the index. Okay, so I'll use the iLock function where I'll say lock. I'll lock the index, and then I will say that the first thing I want to lock is the index. That is, I'm saying the I. So I, and then where do I want to focus? I want to focus on the do not contact. Okay, so do not contact. I'll copy it, and then I'll paste it, and now I'll close this. So the next thing I'll say that if this is equals okay y, if it is equal y, then what do I want to do? I want to do df dot drop. So I want to do df dot drop, and what do I want to drop? I want to drop the index. Okay, I want to drop from the index throughout. Okay, so I'll say I, and I'll use in place. The in place function would actually help me to it will help me to replace it. Okay, it will help me to replace it permanently. That is what I'm trying to replace it permanently. So I'll say in place, and I'll say true. So then I close this particular one. So once I close this, okay, once I close this, I can now run this. Good, it has worked. So once we didn't get any error, it means that worked. So I'll call the df again and see what happens. Oh, so from the do not contact, we don't have any yes again. Unlike this one, where we have yes, we have yes, we have yes. You can see now that we don't have any yes again. So it means that we have finally dropped all those things. So this becomes a clean data set for us, where all the people that are left on our list, they can be contacted. All the people that are left means that we can actually contact all of them. Okay, so that is what we have. So this should be good. So our data set now looks very good and clean. Okay, it looks good and clean. So we can just end this here. But however, because the indexing are not okay, I can reset the indexing. Okay, so that it look good for us. So we can try to reset our indexing so that they will all be good for us. Okay, now before I reset the indexing, what I want to do, the next thing I want to do is that these spaces are not good. So I want to drop all these spaces. I want to drop all these spaces so that the list will be only those that can be contacted. So we have a clear understanding that okay, the people that are left on the list from the first to last, all of them can be contacted. We don't want to have space inside there. Since they said they don't want to be contacted, we don't need them on the list. So we can try to remove all of them. Okay. So I'll use the same format that I use over here. And in that case, if that is the case, I'll just copy the same thing. Okay, I'll copy the same thing and then come and paste it here. Now here, I can change this one and use X. I can use the same X, but I just want to change it. Okay, so I want to change it so that, but the column I want to focus on is the clean. I want to focus on the claim phone number. So I want to change the claim phone number. And now I want it to be like, okay, when you see space, when you see any empty, remove it there. Okay, when you see any empty, drop it. So I'll run this, and now df. So you see our list become smaller. We don't have any space inside the phone number part again. Good. So you have finally dropped everything, and this looks very good. Okay. Now, what I want to do again is that perhaps I can change the phone number column name so that it will just be only phone number. But it can also be the same thing. So let's just leave it the same thing. What I want to do next will be like maybe everything look good. You can use this. Everything look good. But however, it look like, okay, this part, the indexing, it's not nice. We have 0, it jumped to 4 to 7 to 9. So let's reset the indexing. Okay, let's reset the indexing. I'll say df is equal to Then I will say df dot, I'll use reset. So I will say reset index. So I will reset the index, and then I will say that drop should be true. Okay, so what I'm doing over here is that drop all the index you have, then you reset it from 0 to 1, 0. You reset it from 0 to wherever you are going. So drop the old ones and then reset the new one for me. Okay, so now once I've run it, and then I can use df. So you can see that it has now started from 0, 1, 2, 3 up to now. So now this become our final clean data. This become our final clean data, which we can give to our client. Okay, we can give this to our client so that they can use. So this is the end of the data cleaning. In fact, the data cleaning process consists of so many things, depending on the data that you are using, depending on the requirement or what you want. Okay, so however, as you continue practicing and using so many other data sets, you will be coming across so many other complex ways that you can also clean some of the data sets. However, what we have done so far contains a lot that you can use to clean so many other data sets. So this brings us to the end of part 1. Okay, this brings us to the end of part 1, and we will be starting part 2, which is the exploratory data analysis. Okay, all right. So we will end part 1 here, and then we will move on to part 2. Okay, so we are about to begin part 2. Okay, if you are new, kindly subscribe to the channel, and remember to share with your friends as well. Okay? It's not too late to share with anyone that wants to join the bootcamp. If you're also a returning user, returning subscriber, kindly share with your friends as well, and also don't forget to like the video. Okay, so let's move on to part 2. Okay, let's just close this, and then let's go to the when you close it and you come to the running tab, you will see your running all the kernels that are running. Okay, just shut all of them down, then you go and create a new. So you want to start again, and then you go by creating a new you create a new kernel, a new Jupyter notebook. So we would rename it as, let me rename it as EDA. Okay, so let me just say EDA. So just name it EDA. Now over here, the data sets that we will be using we will be using the, what do you call it, the second data set, which is the homicide by country. Okay, so we are going to explore the homicide by country data set so that we see what is actually happening over here. Now over here too, before you start, we will need some libraries. Okay, one of the libraries that we are going to use is the Plotly, the Pandas, the Matplotlib, and then the Seaborn. If you not install all of them, you just have to start by installing them with exclamation then pip install. Okay, the first one is the Plotly. So you have the Plotly. Then the next one will be pip install Pandas. Then we also need the Matplotlib. So pip install. Then we have the Matplotlib. We have the Matplotlib, and then you also need pip, because we are going to do a lot of visualizations. That is why you can see that we are having the Plotly, the Matplotlib, and then we are also trying to install the Seaborn. So you have the pip install, you have the Seaborn. Okay, now if you once you write all this and then you run, it's going to install all these libraries for you. Okay, now because I've already installed all of them, I won't run them again. So let me just comment them. Okay, so I can just comment them before running. Now let me import them. I've already installed them, so let me import them. So maybe I'll use this to write comments. So we have, so the first one is import. I'll say import pandas. Import pandas as PD. And then I also want to import maybe the matplotlib. So import the mat. Have the matplot, the matplotlib dot pyplot as PLT. Then I'll also import, I'll import Plotly. So Plotly dot express as PX. Okay, so which library? Okay, the Seaborn. So import, we have the Seaborn as XNX. All right, so these libraries are okay. Then I can now run. I can run them to import all the good. So now my libraries are all ready. The next thing I'll need to do is to that is load my data set. So I'll say load data set, then df is equal to, now the data set I want to use is this particular one, and it's a CSV file. Okay, so because it's a CSV file, I have to import it by read CSV. Okay, so this is the data set that I want to use, and it's a CSV file. Okay, you can see the one, when you open it, you can see there we have the delimiter as comma, which means that it's a comma separated value. Okay, comma separated value. So I want to copy the whole of whatever that is here. And then I can just cancel it and close this. So I'll now come and say df dot read underscore CSV. Okay, so underscore CSV into bracket, then I'll paste the name of the data set. Then I can now close this. Okay, so once I close this, let me run it. Oh, so df is not defined. Oh, it's supposed to be PD. Sorry. So PD. Good. It's supposed to be, we are using Pandas to read the data set. So now let me check the data set. Okay. Let me just check a few of them. So let me say df dot head. Then I want to look at only 5 of the 5 rows. So let me see. Good. So now I can now see that, okay, the data set, upon looking at only the row, the 5 row of the data set, I can see we have the columns, we have the region, we have the sub-region, rates, counts, and year. So from the look of things, since the data set is a homicide data set, it could be that the count is counting the number of killings, the number of homicide that have been committed. So that is what the count is doing. So perhaps let's just say that it's the killings, okay? It's the killings that have been, and then the rate maybe, okay, the rate at which it's happening. Then the region. So the regions are there, and then we have the sub-regions. So the sub-regions are actually inside the region. So when you take Asia, we have sub-regions where we have the so many other regions. When you take Africa, we have the Northern Africa, Southern Africa, Middle Africa. Europe, you have the Southern Europe. But if you take America as well, we may have like somewhere like maybe South America, North America, and yeah, we could have something like that. So that is what we can see over here. The locations, okay. So it's like when you take the region and the sub-region, you also have the location that is specified, okay. So that is what we can see over here. Okay, so that is giving us a bit knowledge. However, we also want to look at how big the data set is. So, for example, how many columns and how many rows. And with that, we will do df.shape. Okay, df.shape, and then I can run it. Good. So it's now telling me that we have like 195 columns, rows, 195 rows and 6 columns. So the columns are the 1, 2, 3, 4, 5, 6. So you have the 6 columns, but we have 195 rows. Okay. Now the first thing that we also need to check is that let's check if we have any empty value and a duplicate inside. Okay. So I would use the word, I'll say df dot, okay, is now. Do you have any of them like that? And what I want to do is I want to sum them. If you have any now, sum them for me and let me see. Okay, so all right. So you could see that this particular thing, what it's doing is that it's checking the location. It's checking the location. If there is any null value, it will sum all of them up. But here we are seeing that, okay, from the locations, when it sum all the null value is 0, the region to 0, the sub-region the same thing, which means that there is no null value. Okay, so this is another something that we can also see, that how we can also check if there is any null value. Okay, all right. Now we can also check if there is any duplicate. So df dot duplicated. So duplicate, no. You can see clear there is no duplicate. We don't have any duplicate inside. Since we don't have any duplicates inside, we can just move on with our data set. Okay. The next thing that we also want to look at, let's check what is the type of all these data sets. Okay, are they integers? Are they floats? Are they string? Are they dictionary? Let's check all of them. So we will do the f dot here. We will use the type. Okay, the types. Okay, so we use the types, and just like that, and then we run it. So once we run it, so you can see we have, these are the things we have. Okay, we have object, and then the rate is a float. From here we can see the rate is indeed float, is 6.7, 2.1, 1.3. So that is, it's a what do you call it, a float. So I think once we are satisfied, we can just keep on moving with data set. If should we not be satisfied with any particular data type, we can just change it. Okay, so for example, let's assume that we are not satisfied with the data type of rate. We are not satisfied. We want the float. We want the float to be rather be integer, not what do you call it, float. So we can just say that we can change it over here by, we say df. Okay, then the column name. What is the name of the column? It's rate. So you have rate, then we close it, and then we say is equal to df, then also rate. So rate, then we close this dot, then we use as type. Okay, as type, because we want to change the data type, we use the as type functions, and inside we specify the data type that we want. We want int. Okay, we want to change it to int, so we just do it this way and we run. Now if I check the data type again, or if I just call df, if I call df, you could see that it has changed them from the decimal to now float now. Okay, sorry, for that, what do you call it, integer now. If I check the data type, okay, df dot the type. Okay, so if I try to check the data type again, okay, if I try to check the data type again, I can see that the rate is now integer. At first it was float. But now it's now integer, showing that our data type has been changed successfully. Okay, now let's try to rearrange the count, because our focus is on the count. We are trying to explore the data to understand the counts of the homicide that has been committed. So we are trying to explore the counts. So let's do something like, okay, we want to sort it in descending order. Let's sort the counting in descending order and see what we are going to get. Okay, let's try to sort it in descending order and see. And I'll try to do that and save it in a new data set, a data frame. So let's say that df1. Okay, so df1 is equal to, so let's say df1 is equal to df, then I want to do sorting, like sorting. So I'll say df dot sort value underscore value. Okay, df underscore values, and then what do I want to sort? I want to sort the counting. So I'll use the head and the column heading, and then I want to do it in descending order. So I'll set the ascending order to false. So now I can close this. So when I run this and I call df1, it should sort everything for me. So you can now see that it has sorted the count in descending order. Okay, because I set the ascending order to false, it has set it to descending order for me. Okay, now we see location over here. We see locations and we see count. So what I want to do is that the first thing I want to explore the location and count. Okay, I want to explore the location and count. So I'll try to set this the new data set I've created. I'll try to separate them. I will only pick the location column and then the count column. Okay, and then visualize the two of them to see what is actually happening based on each location. Okay, I don't want to just only visualize it in region. So I'll pick the location. The locations are just like somehow like countries by country. So I'll try and pick only those things. So I'll say my df1 is equal to, okay, df1, because I've already sorted this one. I've sorted this part to descending order. I'm focusing on only that one. So what do I want to pick? I want to pick the location. Okay, I want to pick the location. And the next thing I want to pick is the count. I want to pick the count. Okay, and then I'll close this. And let me look at only the first 5 by using head. So head 5. So now if I say df1, it should give me only 5 of them. So it should give me only 5 of them, the top 5. Okay, it should give me only the top 5. So once it has given me the top 5, I can see Brazil, I can see Nigeria, I can see India, and I can see Mexico and United States. So let's say that I want to only plot these top 5 and understand the data. I want to only plot these top 5. If on the other hand, maybe I want to, let's say, I want to focus on rather 10. So, and let me rerun this. Okay. So even though I specify 10, it's giving me only 1, 2, 3, 4, 5. Okay. So you can let's check what is happening here. It's picking the locations, all right. Now let me rerun this and see. Oh, okay. We have this. Let me try to just take df here, and then over here I just created a new one. So I now have the full df1. So now I'm only picking, I want to pick the head of this. Good. The reason why that happened is that because the df was saved with only 5 columns. So when I try to change it again, it's not working. So once you go and rerun it from the top, it should now work for you. So you can see that the first 10, okay. So I now have the first 10 of it. Now if I run this one again, to still give me only this 10, unless I go to the top and start running all of them again. So now I've gotten this as my data set. So let me try to see if I can plot. Okay, I want to create maybe a pie chart out of this and look at and actually visualize this data very well, so that I will understand what is happening. With just a mere values, it may be very difficult for me to understand. So I'll use I want to plot pie charts, okay, and I want to use the plotly function. So I'll say df1 dot plot. So df1 dot plot, and the x, I'll specify x. I'll say x is equal to, the x should be equal to the location. Okay, so I'm trying to use the x as location, and y, the y column, and the y, I want to use the count. So with count, and what kind of charts do I want? What type of chart do I want? I want pie chart. So in this case, I'll use kind, and I'll say equal to, then I'll have pi inside. Okay, then I want to label it. And how do I want to label it? I want okay, let me just run this and let's see what we see. Good. So you can now see we have, it's using the numbers rather to represent all of them. So this is our pie chart, but let's do some editing to remove some of them. Instead of this value, I want to, instead of using the count as the label, I want to use the location name as label. So inside the chart, inside again the plot, I will use the df, I will say label. Label is equal to df1. So df1 dot location. So df1 dot location. So let me run this and see what we see. Good. So it has now changed the location. It has now changed the value to location. Now this legend here doesn't make the thing look nice for me. So I want to go and get rid of the legend. With this one, I'll use the plt dot, then I'll say legend. Okay. So legend, and then dot, I'll set the set value for the set underscore value. Okay, sorry, I'll use visible. It's visible. So visible, I want to make it false. I don't want it to be visible, so I'll use the false. Good. So you don't have the legend over here again. Now this alone doesn't make it doesn't represent anything, but I want to make sure that I've been able to get the values, maybe a percentage. Okay, a percent, what is happening over, I want to calculate a percentage over here. I can do that calculations over here. Okay, I can do that calculations over here where I'll have the count percent as well. Okay, similarly, I can create automatic counts inside this particular value over here. With that, what I will do is that I will try to use the auto PCT, and with that one, it will help us display the percentage automatically within each segment of our chart. Okay, so over here, I'll inside the chart again, I'll say, I'll put comma there, and then I'll specify auto PCT, and I'll say equal to. Okay, so equal to, then I'll put this in quotes. Now I want it to, auto PCT will do automatic calculation for me and specify the result inside each segment of the chart. So for example, for Nigeria, it will put a percentage inside. For India, it will put the percentage inside. But which number of decimal point do I want? So I have to choose that particular decimal point, and I'll choose that with a percentage sign. Then I'll say 1 point, maybe I want 2 decimal place. Okay, and then I'll put F around it, and then close it with 2%, and then close it like this. So once I run this, it should put percentage inside for me. Now the first percent that I specify inside is the one that is inside. If, for example, if I didn't put that one inside, okay, if I didn't put that one inside, it will just calculate a value inside for, okay, it's giving me error. Okay, so you see what happened. So when you put, you don't put the percentage inside, well, it's actually going to give you an incomplete chart. Okay, so let's go back to, good. So this is enough. Okay, this is enough. Now if we think that the chart is even, it doesn't even look good, when you put the percentage, when you read over here, you see that everything is cumbersome. So we can just go back to our data frame, and then let's try to make it like we only want the top 5. So yeah, let me try and just use only the top 5. So it has given me only the top 5. Now let me use that top 5 to draw. Good. So now I'm using only top 5 to draw my chart, which looks very good. Okay. Now here, over here, I can now see that if you look at the over here, you can see that even out of the 5 that we are doing, because we arrange it in descending order, this is the top 5 counts that we are having. And you can see that out of the top 5, it was Brazil that was leading, followed by Nigeria. And when you look over here, each of them has been represented by their percentage. Okay, so this is giving us a clear understanding of what is actually happening by locations. When you look at each locations, we can see that, oh, okay, so the count of homicide committed over here, Brazil is actually leading with a percentage of 25.02. Okay, and then now followed by Nigeria, India, and then we have Mexico and United States. So this is what we are seeing. Okay, but we are not done yet. We need to explore the data further. Okay, so we can, the next thing that we can look at is that we will try to look out for maybe what if we want to understand the data by region. Okay, how do we understand this particular data by region? So let's try to sort out the regions. So let's group by region and see. Let's group the main data by region. So group by region. Okay, let's group by region, and then let's see. And this time around, I want to create a new data frame. Okay, out of the original data frame. So df then dot group by. So group by, and then I'll specify I want to group by region. So I want to group by region. Okay, so what do I want to? I want to also, once I'm grouping by region, I want to sort it by counting the number of homicides. So I'll say that the next I'll open square brackets and I'll specify count inside. So count, and then I close this like this. Then I sort value. I'll sort the values. I'll sort the value in ascending order. So ascending order, I want to make it false. So still I want to look at it from the top to down. Okay, so count is giving us, you say that was series group by object has no attributes, sort value. Okay, sort value. All right, if you are getting error, so let's first of all sum the count before we can sort the counting by value. So here I'll go back, I'll say dot sum. So let me go this way. Okay, this has worked. And now let's say df2. Good. So you can now see we have what you call Americas. The Americas, wow. It has actually summed up all of them for us. Where we have that is, I think the Americas over here is actually representing North and South America. And we have the Asia, we have the Africa, we have the Europe, and then we have the Oceania country as well. So I want to change, first of all, I want to change these Americas to maybe North and South America. Because when you look at the data set, we have United States, we have Mexico. And these two are either, they are two different, we have either the North and South America together. So I want to change the data type, sorry, the data set to that. Okay. So what I will do is that I'll make changes where I'll replace the Americas with North and South America. So I'll say df, okay, and I'll use it to replace the original data set. So I will say that df, and then I'm looking at the region. So I'm looking at the region, and I'll say is equal to, then, sorry, I'll actually do dot replace, and I want to replace the Americans. Okay, So I'll replace this one with, what do I want to replace it with? So I want to replace it with North/South America. Okay, so I think this will be okay. And then in place, I want to replace it permanently throughout the data set. So in place equals to true. So let me run this. And now let me check df. So if I check df, good, this is what we have. Now if I go back to go and take my df2, if I rerun this particular one, I should be able to get my Americans change into North and South America. So let me try and see. Okay, it has not changed. So let me just copy the whole of this one. I can run it here. So let me just, but because I want it to be below what I'm doing, I will just copy it and then come and replace it here again. So now df2. Good. So as soon as I change everything, it has now worked. So I now have this. Okay. So right now, what I want to do is that I want to use this to plot a bar chart so that I will visualize what I'm seeing over here. Okay. So what I'll do is that I'll say df2. Then I want to plot it as a bar chart. So I'll use the plot function and do df2. And then inside, I won't specify anything. Inside, I'll just say kind. And then kind is equal to, I want bar. Okay. So I'll just close it. And now let me run this and see what I get. Good. So once that I run it, I can now see it as a visual. But I want to suppress this particular outcome. So let me use plt dot show. Good. So it's gone. So here I have the region, and then I can name the others. Okay, I can just name the others where I will make the kind of, so let me say plt dot. So let me use plt dot y label. So let me say sum of counts. So let me see. So I'll rename that. I'll just change the distance, and then here is region. Okay, so I can give a title as well. So plt dot title. What I've visualized is actually counts of homicide by region. Okay, so I can just give it as maybe count by region. Okay, because we know what we are doing, or count of killings by region. So here, let me use the count of killings by region. So I can close this. Now when I run it, I should get my title, count of killings by region, and then I have sum of counts, and then I have region. So this will help me understand what is happening when we take from when we take all the regions that are involved in the data set. You can see the region that is leading in the count, the one that follows, and then the up to the last one. Okay, so this is how you can also visualize this one as well. Now I have done that of when you look over here, we've done that of locations, we've done that of region, but the data set also specifies sub-regions. We also have sub-regions, which means that we can also try to visualize by sub-region as well. Okay, So let's try to pick out all the sub-region. Let's group by sub-region and see what is happening to the sub-region as well, because all this will give us a deeper understanding. After we have been able to establish that, oh, okay, so the country that is, the location that is leading, we also establish the, even though Brazil was leading, followed by Nigeria, that enough, that alone will not give us enough evidence to conclude whatever we are doing, to conclude the country that is leading. So we also need to understand by region. And now we have been able to establish that it's actually North and South America that is actually leading, followed by Asia before even Africa. Okay. Now that one too, we also need to, okay, what if we want to look at it in the sub-region? We want to look at it based on sub-region. Okay. So let me also group by sub-region again, so that we can also look at sub-region. So group by sub-region. So group by sub-region, and I'll create a new data place. I'll do that data frame as df, then dot group by. So what do I want to group by? I want to group by sub-region. So I want to group by sub-region, and then I want to count. Okay, I want to sum up the count. So I'll say count. So I'll say count, and then I'll dot sum. I'm looking at the sum, and I want to sort the value by descending. So I'll say sort underscore values, sort underscore values ascending. Ascending should be false. Okay, so ascending should be false. And then let me look at df3. Good. So looking at df3, I can now see that, okay, so we have the South America. This is what we are having: Southern Asia, Central America, Western America, Southeast Asia, Eastern Africa. So you can see all of them also from grouping in descending order. Okay, now we can also visualize this. Okay, we can also visualize this, but because how can we visualize it? That's the next thing that we need to ask. You can use the bar chart to just visualize this straightforward. Okay, you can use the bar chart just to visualize this. Okay, but let's also utilize the seaborn to also try to visualize what we are seeing over here. Okay, so let's try and see if we can visualize this. Okay, let's see how we can visualize this. Let's say S and, okay, we want to use seaborn to visualize this. Dots. Okay, if we want to use a seaborn, then we have to make sure that we have a column. We have been able to change this to have maybe X and Y axis. Okay, because if not that, then we have to use the bar plot. Okay, but because we want to use a seaborn, then we have to make sure that we change the whole of these ones as. Now when you look at these ones over here, the whole of these ones, we have the index for it, where we have the index and then the value. Okay, so let's look at the index. So df3 dot index. Okay, so you can see that all the names over here represent the index. Okay, and then if we take df3 dot values, df3 dot values, it should give up the values over here. So let's use the index and then the values to plot our bar plot. Okay, so let's say seaborn SNS dot bar plot, and then the X value, let's say df3 dot index. Okay, so we are using this one to represent the X values, that is the X column, and then the Y will be the value, df3 dot value. Okay, df3 dot values. Now you can close this. Okay, so let's try to run it and see what you get. Good. So I'm getting a nice bar plot, but the names are not showing. Oh, so let's try to make the name so that they will be vertical. So let's come here. So let's see, you use a PLT dot. So we want to use something called the X stick. Okay, this one will help us to be able to change the rotation of the values in that is the X axis, whether horizontally or vertically. So we use the X stick, then we say rotation. Rotation is equal to, then we want to make it vertical. So we want to make the rotation vertical, then we close it. I also want to hide this rating over here. So let me say plt.show. So this plt.show will suppress this particular output over here before the visual. So when I run it, good. So now it has changed this ones to vertical for me, and this is exactly what I'm looking for. So over here too, even though we have been able to establish that America is leading, followed by Asia, this has given us a more understanding that the leading America, what makes America becomes the leading over here. When you look at over here, what makes American leading? Okay, what makes Asia follow? So these ones has given us a more understanding that, oh, okay, so for American to lead, it is South America, Southern Asia, Central America. These are, and when you add the South America being the first leading, plus that of the rest of the American countries, you realize that indeed America will be leading. Because even the South America alone, look at it, you can see that it's almost approaching 80,000, okay, 80,000 counts, which means that indeed there is a reason why America is leading. So here too, you can also give it some title, okay. So you can say plt dot title, then we will say that, okay, it's just as the way we say, we name this one as count of killing by region. So we can say that, name this one as count of killings by sub-region. Okay, by sub-region, and then already the X axis has been given us as what do you call it, sub-region. So we won't worry about that much. We will go to the plt dot y label. Y label as sum of counts. Okay, sum of counts. So when we run this, now we have our plots labeled nicely. Okay, so this is what we have. Now, even though we have done this, the question is, are we satisfied with our whatever we have? Can't we go a bit further to look at that of other countries as well? For example, maybe where we focus on only the top two. Okay, so maybe we can focus on only, if you look at over here, okay, the top regions are, we have the Asia, we have America. We can also focus on only the Asia and then America, the top two regions. Okay, so let's look at only the top regions. Let's focus on only the top regions. And for that one too, we are going to extract those values, because we now have we have now established that it's America and Asia that are leading. Okay, so let's take the rest out and focus on only the two of them, or perhaps you can focus on the three. Okay, that is the three leading regions. The three leading regions. You can focus on the three leading regions, but with this one, we are just going to focus on only the two leading regions. That is North and South America and Asia. So let's also do some kind of grouping. Let's extract those two regions from our data set. Okay, so let me say that extract. Okay, So extract North, that is North or North and South America and Asia. Okay, so this time around I'll create a new data set called data df for data frame 4, and I'll pick it from the main original data set. So here I'm interested in only extracting the Asia and then what do you call it, North and South America. And what I will do is that I will say that, okay, if region is equal to Asia or region is equal to what do you call it, North and South America. Okay, so that is what I'll try to do. So over here, let me open the parentheses, and inside the first one I will specify, I'll say that df, then my region should be either n/s America. Okay, oh sorry, it's supposed to be region. Okay, here it's supposed to be region, so I'll say region, then I'll close this and I'll say that equals, then what do I want to extract? I want to extract North/South America. So then I'll close it, or okay, and I'll use this line, this one for or. Okay, then I will say that I'll open another. I have to close this parenthesis. I didn't close it, so let me close it. So now I will come and say that I'll open another parenthesis and do the same thing for that of the, I'll say region, then I'll close it. So equals Asia. Okay, and close this one as well. So once I'm done with that, let me close the square bracket and then I can run it. So now if I call for df4, it should give me, oh, it has given me everything once again. Good. So let's see. Yes, it has extracted everything for us. It has extracted based on these particulars that we want. So you can see that when you look at the region area, you can see we have only Asia, North or South America, Asia, North and South America. We don't have Europe inside. We don't have any other thing. And even the rows has been reduced. The columns too have been the columns is the same. The rows have been reduced. So what we wanted to do has been satisfied. We only want where we have the region to be either Asia or North and South America, and these have been achieved. Okay, so right now we have done that successfully because that is what we are only interested in. Okay, now we have been able to do that. So what the next thing that we want to do is that let's look at the years. We can't deal with all the data sets, so let's just look at the years. Okay, so let me look at the years and see what is happening. So df4 dot, so I want to see the years. So you can see that the years we have at something like as low as 2011 inside. Okay, we have as low as 2011 inside, where we have as high as 2020. Okay, so let's assume that I don't want to look at all the years. I want to look at the latest years. Okay, 2011 is far away, so let me just focus on maybe somewhere like from 2020 to 2016 to 2020. Let me focus on only those ones. So that one, I'm going to extract only those data sets and now save it in my df4. So data frame 4 will now be equal to the data frame 4. I'm focusing on trying to extract only the where we have the year up to only 2016 inside. So I'll open this df4 and then I'll say that the year, okay, try to extract the year for me. So you have the year, then we will say that if this is greater than, okay, strictly greater than 2016, which means that I'm not trying to include even the 2016 inside. Okay, so I've closed this one. Then I would say that, oh, okay, so what do I want? If the year is greater than 2016, which columns do I want to extract? I want to extract the region, the year, and the count. I want only that 3 columns. So that is what I'm extracting. So I want to extract only the region. Okay, so I will say extract the region for me. The region. Then the next one I want to see is that I want to see the year. The next I want to see is that I want to see the count. So this should work for me. Okay, so I want to extract those columns. So now let me check my DF4. So you can see, yes, we have been able to extract only the region, the year, and the count. Okay, so this is what we are actually interested in. And now if I check the year again, DF4 dot year, if I check this again, you see we don't have any 2013, 11, 17, and those things inside. So this means that we have been able to achieve what we are looking for. Okay, so now that we have been able to achieve what we are looking for, let's try to group it. Okay, let's try to group it by the year, so that we have something like, okay, we have the region column, the year column, and then we have maybe the count as well. Okay, so let's try to extract that one. Okay, let's do it that way. Let's group this we have over here, where we have the region, the year, and then the count, where we do that in a proper way. So with that one, I will group by region and then sum of counts. Okay, so let me give a comment and say group by region and sum of counts. So region and sum of counts. So now I'll do my DF4 again. I'll replace this by DF4 dot group by. Okay, then the group by, I want to group by region, so group by region. I want to group by year, so I just want to group by only these two. Okay, so I want to do this. Now what I actually want to do is like this. Okay, let me just show something. What I want to do is that I want a way where, for example, maybe I'll have if I take, because I'm looking at Asia and America, I'll take maybe the first one, America. Okay, I'll take maybe, so I'm looking at North and South America. So I will say that North/South America, and then I'll have the year here. Then I'll have count here. Now over here, the North and South America, all the years should represent. We have all the years, and then we have the count as well for each year. Before I will come back to what do you call it? I'll come back to Asia. Okay, where that one too we have the year, and then it is special. This means that this one will be the region. Okay, so this is how I want to group by. Okay, so it means that to come here this way, we have the North and South America followed by that order. So that is how I want to represent my data set right now. So because I will do that, I'm trying to group by the region and then the year. And now what I want to do is I want to sum up the counts for each of them. Okay, I want to sum up the counts. So I'll say counts, and then I'll put this like this. So let me run this and then now call my DF4. Good. So exactly what I'm looking for. Now I have the Asia, and then the year followed like that, and the count, and then that of the America also for this. Now the next thing is, since I've been able to extract this, I want to use this to do probably a plot. Okay, but I can't use this to plot. So what I will do is that I will try to change this to a data frame. Okay, I'll try to change this to a data frame. Then I will see if I can be able to use it to draw any kind of maybe bar chart. So to do this, let me create a new data frame out of this. Let me say new data frame. Okay, let me give a comment and say that convert df4 to so let me say data frame. So now I will specify new df4. So let me say new df4 is equal to, then df4 dot, I'll use on, there is a function that we use that is called on stack, and it will help us change whatever we have. Okay, so it will put just as the way we want it here. It will actually put it into a table for us, but in that case it will work like the way transpose in Excel work. Okay, so it will actually change this one where we have the Asia and North America will now move to this side. Okay, so it's actually going to work this way, where you have something like the region. Okay, you have region, and the region you have it will move this way, where you have probably the Asia North/South America, and down the region this is the first heading, but we have year. Okay, so you have the year, then you have the year represented, and then each of the data will also represent it. Okay, so these ones will be the account. So this will be the account. Okay, so it's like all these ones are actually the count for each year. So that is how it's going to, that's how I want to read. So the on stack is going to help us be able to achieve this particular what we want to achieve. So I'll say that on stack, then inside we have to specify level. Okay, but let me run this and see if I'll get any. So new df4. Okay, so it has changed this, but this is not how I want. So let me specify, because it has given it its own level, but this is not how I want it. So I will give a level. I'll say that level equals 0. Okay, so now if I run this, good. So if I run this, it should give me this, and this is exactly what I'm looking for. Okay, so now I can use this to plot a bar chart so that I can visualize this very well. Okay, so now you can see we have not a value here. This is just showing us that 2017 North America, there wasn't any count there. The same as 2021, there wasn't any count there. So this, it shouldn't give us any much problem. It's just telling us that we don't have those things over there. So I'll use the new data to plot. I'll say new, because I've changed this is the new name, df4. Okay, so I'll say df4.plot. So df4.plot. What kind of plot do I want? I want a bar plot. So I'll say equal to bar, and then I'll close this. Okay, so if I run this, I should be able to, good. It should give me a good result like this, where you have this one representing the North and South America. Now I want to label my data. I want to label my plot. Okay, so the first one, plt dot title. The title, I'll say, so count of killing. So let me say count of killing, and this time around, because I'm focusing on only North America, and so count of killings in Asia, and so North/South America. So The next one is PLT dot, and the X, what do you call it? The X is already labeled for us as year, so we won't waste much time. So I'll say that Y label. So Y label, and I want to make it like sum of counts. So as usual, sum. So sum of counts. And then I want to suppress this outcome over here. This thing I want to suppress. I don't want it to show. So PLT dot show, and then I'll close it like this. So once I run it, good. This gives me a good result, showing that, oh, okay, so in 2022, that was where North and South America had the highest count. Okay, they had the highest count over 120,000 counts. Okay, so that is actually counting for they representing the first, or they showing the highest over here. Okay, when you look over here, that is what is actually counting. So now we are now breaking everything together, and we are now understanding what is actually happening. Okay. Okay, so the next that we will also want to look at it, we also try to, since we have gotten the understanding up to this point, we can try to say that, oh, okay, so what if we want to look at the year and region all together? Okay, now we want to, because we now understand that, okay, this year, this is what is happening. What if we want to look at the whole data set, and we want to look at maybe we don't want to just extract only a portion, but this time around we want to look at the year. Okay, we want to look at the year, the region, together with the count all together. Okay, what if you want to look at that one? Okay, so let's try and see that one alone. Okay, and plot that one too and see. So over here, I'll create a new data set, a new data frame again, and this time around I'll say df5, because it's equal to, then I'll extract the year, the region, and the count from the main data set. Okay, so I have this, so I'll say I want to look at the year, I also to look at the region, and then I want to look at the count. So once I want to look at the count, so now I want to continue. Once I've done this, I've extracted this out of it, I'm not done. I want to try to group it, the year and region. Okay, just as the way I did over here, I want to try to do the same thing for the whole region, and count them as well. So let me do the same thing by group by. Okay, so let me know df5. So I'll say df5 is equal to df5, then dot group by. So group by. So, and I want to group by, what do I want to group by? I want to group by first the year, and second I want to group by the region. Okay, so I want to group by these two, then I want to sum up the count. Okay, I want to sum up, do a dot sum and sort it by values. So sort value. Okay, sort value. And what do I want to sort by? I want to sort, then I'll put by. Now I don't want to sort either in ascending order or descending order. All that I'm trying to, I will do the ascending order, but I want to make sure that I'm trying to sort it year by year. Okay, I'm trying to sort it year by year, where it will start from the highest year to the lowest year. Okay, so I want to start, if the data set is starting from 2021, as you know, the data set is starting from 2021. So I want to start my counting. I want to look at from 2021 downwards. How is it being represented? So I'll say sort by. So the by section, I'll say by is equal to, I want to look at the year. Okay, and then now I want to look at it in ascending order. descending order. So I'll say ascending equal to false. So ascending is equal to 4. So once I do this, let me run it and now call df5 and see. Good. So now this is what I'm seeing. So you can now see that we now have each of the region. All the regions have been represented here. So you have I try to sort it by year and in ascending order as well. So you can see that the year has been sorted in descending order. The count too has been sorted in descending order. So 2021, you can see that the count is only found in Asia, where they had over 15,000. When it comes to 2020, we have the Oceanians also representing the North and South America, the Asia, the Africa, the Europe. When you go to just like that, you can see all of this like that, okay? So I can use this data to plot a bar plot, okay? So that I will visualize this, not in this way. One of the easy way to understand this is if we plot this. So let's plot this particular thing so that we can actually understand it from head to toe. We can actually understand what is happening over here. So I'll say df5 dots. Then I'll use the plot function, plot. What kind of plot I want? Bar plot. So bar. Then let me try and plot it and see. Good. Now this look too small for me, so I'll try to increase the figure. I'll try to increase the frame over here so that at least it will occupy here. And to do that, we have the fig size. So I'll say fig size, okay, is equal to, so fig size, and I'll open brackets. I want to make it like, okay, over here the length and width, I have to specify the length and width. So I'll say 12. So let me choose 12 and say maybe by 8. Okay, so and close it. Now let me see. Good. This look good. This look good for me. So now what is left is at least decorating this chart with title and start. So plt dot. So title, and then the title, I want to say that maybe sum of count. Okay, sum of count of killing by year and region. Okay, so when you look over here, we have year and region showing the end. You can see that each year it's being represented. Okay, it's being represented. Each year is being represented, and the country is also being specified. That is very good to visualize. So you see that I'll say sum of count of killing, sum of count of killings, maybe by year and let me say region, and then plt dot y label. The x is already labeled, so I won't label it again. So here I would say, as usual, sum of counts. So sum of count, and then I want to suppress the rating. Okay, good. So we have a very nice visual, and then this has also given us a lot of understanding. Okay, so this has also given us a lot of understanding. Now let's just look at one or two things also. Okay, now what if we want to look at the average count? Okay, we want to look at the average count of each of all this. For example, maybe we have been looking at the total counts all this while. So let's try to break it down and look at the average count as well. Okay, so how do we get that? So with that one, we will try to create a new data frame. So let's say df. Now I want to create it as df6, but let me give it a comment. So let's say I'm interested in average. Okay, so average count. So average count for maybe average count for each sub-region. Let me focus on only sub-region. So average count for each sub-region. So now df dot, I want to group by. So df dot group by, and then the first thing that I want to look at is the sub. I want to group by the sub-region. So sub-region, and then I want to focus also on the count. So now I'm grouping and I will count by. So I want to count. And now I'm interested in finding the average of all the counts. Okay, so I'll use the mean function. Okay, so I'll use the mean functions. And once that I use the mean, I will sort, because I want to look at it from, what do you call it? From the top to down. So I will use a sort value. So sort values, and inside I will specify, I want it descending order. So I'll change the ascending to false. Okay, so this will help. And df6, if I call df6, good. So so it has given me this with so plenty decimal numbers. I'm not interested in the decimal numbers, so I'll use the run function. I want to run into maybe 2 decimal place. So the decimal place is too much, so I just want to run it to only 2. Okay, so let me just call this. So now it has run it to only 2 decimal place for me. So I want to use this also to draw a graph, but as usual, as the way this is, we can't use it to draw, just like the way we have encountered over here. This particular one, we were not able to use it to draw any chart. Okay, we have to change it to this before we can use it to draw a chart. So, and then there is also another one here where we apply, good, this one, just like the way this one, we apply this method, okay, using the index and then the value to draw. We will use the same thing, you apply the same method for this one as well. So let's use this one, the same method, but this time around, I will do that and use it to create a dictionary. But let's focus on that first. So let me see df6 dot index. Let me see the index. This is what we can see the index, and then df6 dot, so values, you can also see this. Now let me create a new data of which will be a dictionary. Okay, so let me create a dictionary combining these two together to create a dictionary which will have the key and the value. Okay, and with the key, I will use the key because I want to use that same thing just to prepare a new data frame. Okay, so this is also another method that I can use to just, instead of using the stack. Okay, so let me name this as data, and I'll say it's equal to. So for here, I'll open how we create a dictionary. Okay, so let me just close the two of them together and then do it this way. Good. So the first key that I want is, I'll name the key as category, and then as usual, you put this there. And what should be the value, what I should give to this particular key, the values for this key. Okay, so this key, the key, or what should be the keys actually. So the category, and then I'll say df6 dot index, because I want to use the whole of this one. I want to use the whole of this one to represent this particular keys. So I'll give comma, and then I'll start with values. So I have the value. Okay, so this one too, and this part will be df6 dot values. All right, so let me just run this. So now let me pick the data, let me call the data, and we can now see that this is the data. if I check the type of data, okay, if I say type data, it should tell me that this is a dictionary. Okay, so this is actually what I'm interested in. I'm actually interested in creating a dictionary, and I've successfully created that. So what I want to do now is I want to convert. So I want to convert the dictionary to data frame. So I want to convert the dictionary to data frame. So this time around, what I want to do is that I want to use this method. I want to say new df6 is equal to, okay, and I'll use the PD, pandas PD dot data frame, and then what do I want to convert? I want to convert the data. So instantly I've converted this particular dictionary to a data frame and save it inside this new, that's new df6. So new underscore df6. When I call that, I now have a data frame. So this is what I have. So I've now converted everything, this particular dictionary, to this with the values. These values are actually the mean of the count, okay, the mean of the count. So now I can use this to plot any graph or anything I want to plot. But here I want to plot it on a tree map, okay. I want to plot this particular one on the tree map. So with the tree map, I'm going to, you see, we actually use so many what do you call it, libraries, okay. We have the Plotly Express. So that is what I'm going to use. I'm going to use the Plotly Express, which is the PX, to do a tree plot, a tree map. With a tree map, it's an interactive visuals, okay, where when you hover your cursor on it, you should see what is happening, each of the values over there. So that is what I want to use. So px dot, then I'll say, so I'll specify the tree map, and then inside I'll specify the data name. So I'll say df6 and then comma. So I'll also specify path. So I'll say path is equal to, the first one is the category, okay. The first one is the category, that is this one, and then we have the path will be the category, so category, and then I'll specify value as well, okay. So I have value, so the values will be, what is the name? It's value. So value, you should when you are doing this, you be mindful of the cases, okay. It's case sensitive, so if you are doing it with a caps, you should make sure that you are using cap. So let me run this, okay. So this should give us a tree map. Good. So when you hover your cursor, you should be seeing the value for each of them, how interactive. See how interactive it is, but it doesn't look good. We have when you hover it, we have labels, value, percent, like parent ID. We want to clear away those things. So, and I also want to give it let me just clear those ones before, okay. So what I'll do is that I will name this. I'll say this is fig. So let me say fig equal to. So now if I come here, I can use the fig. Then I'll use dot update. So I'll say update. So I'll update traces. So I want to update the traces, that when you move the cursor, those things, that thing that appear, okay. I want to update those ones. So traces, and then the keyword is hover template, okay. So you have the hover template. So hover template is equal to, the first one I want to look at is the category. Okay, so category and then colon. Okay, so colon, then I'll move on. Okay, so what I'll put here, I'll put the labels here. So you have the label, because I'm trying to update the label for each category. Okay, so the categories are the names, and you can see that when you hover it, you have labels. Okay, so this is how you update that of the label as well. So over here, I will do this. So this is how I'll specify this. So I have this. So I'm moving to the another one. I'm doing the next one as well. I try to do the next one. Okay. So once I do it for the labels, I have to do it for the value too. So I want to do that of the value as well. So value. Okay. So value. So like this, and then I will have that one too also. And so when we close this, this should update and remove the IDs and value for us. Good. Okay, it has removed them, but the value names we have, I think we have to check it again. We have the value to be percent value. That is not what we are interested in. So let's make the changes. So we have labels, then the value column, you have the value equal to the value. Good. So when we look at it, I think we have made mistake here. The value is not specified well. So let's check. We remove that one. We end the value with L, which is not correct, because the value that we specified is that the spelling for value, it doesn't end with L. So good. So now we have that, and that has made the tree map very interactive for us. So this look good. Okay. So here too we can be able to visualize our visuals very well, where you can see the category and then the value for each as well. Okay. All right. Now let me try to give it a title. Okay. Let me give it a title. So the title, let me specify the title is, so I'll say title is equal to, then I'll say, okay, this tree map. Good. So this look very good, and this has given us a clear understanding of what we have. Okay, so when we hover it anywhere, we should be able to tell what is there, which value is there, and then we should understand what is happening. And this is actually the mean. Okay, so even the title, you can change the title. You can say that, because here we are looking at what we intended doing over here was to find the average count for each sub-region. Okay, so we can say that over here we can change the title so that it will represent each of them, because all these are being represented as the average count. Okay, so we can change the title. Let's change the title to maybe Okay, let's represent it by tree map, okay, of average count. So average count of average count. Let's just show you this way. Good. So you have the tree map of average count. Good. So this is very interesting. This is very interesting. And on this point, we have been able to explore the data from head to toe to understand every aspect of our data. Okay. And this should be enough for us to, if we want to do any further analysis, we can be able to do it. Through this lesson, we have been able to establish our data and explore the data from head to toe and understand what is actually inside this particular data set. Okay. So yeah, this is how we explore data. We do exploratory data analysis to understand our data. Okay. All right. So this will bring us to the end of today's lecture. As usual, if you don't understand anything, if you have any problem, remember to leave it in the comment sections or get in touch with me via WhatsApp or email. I'll be glad to assist you. And also, don't forget to subscribe to the channel and share with your friends. Okay, invite your friends to also join us as we learn data science and data analysis together. This journey is very big and interesting. We can all get there together. So invite your friends, share with your friends, and remember to subscribe. If you are a returning user, thank you. If you are a new subscriber, thank you. Don't forget to subscribe to the channel. All right. Bye-bye.